the relearn packet seems to be going well for a lot of kids. The one thing you don't want to do is put off the relearn packet. You want to get it going as soon as you possibly can. And let me make up a due date for the relearn packet now. You can write this down on your packet if you so choose, or you can just remember it, but I would tend to think writing it down would be a good thing. Hold on. You've had all of this week. The 20th. The 20th of October, the relearn packet will be due. Now, you are going to get a take-home test a week from tomorrow. There's not a lot of time for testing in this course, I don't think. So, every once in a while I give a take-home test. If there's a take-home test, there will be no relearn packet, because you can work together on take-home tests. So, you should definitely not need a relearn packet. And then there'll be one more test at the end of the marking period, and that test will not have a relearn packet because the test will be given right before the end of the marking period, and there simply won't be time to do a relearn packet, okay? So what that means is you have until the 20th, let's get the first grade straightened out. Then you have a take-home test, which I will talk more to you about at a later point in time, but you are free to work together on that, so there's no excuse. Every person in the room should get a high grade. And then last but not least is one test at the end of the market period, and that test will not have a relearn packet, nor will you be able to work on it together. So it's going to be what you get, okay? All right, so let's take a look at these questions. The first one says 3x minus 1 is equal to negative 16. And this is a very standard two-stepper. This should be so simple for every person in the room. It says minus 1, we do plus 1, die, 3x is negative 15. That's a negative sign. Dividing by negative 3, die, x is negative 5. All right, so that's the first question, and that's what I would call the foundation. It's what we build everything on top of. Now the next question, we switch the side of the variable. We talked about this yesterday, and we said we don't change anything. The question we begin in our mind with all of these equations is, what's happening to the variable? I don't say what's happening to the variable on the left, and I don't say what's happening to the variable on the right. I just say what's happening to the variable wherever it might be located. So this says plus 7, we want to do minus 7. Inverses, opposites, die. 3 negatives and 7 more negatives is negative 10, equals 2x. Divide by 2, x is negative 5. So there's the second one. The third one, in honor of Steve Irwin, danger, 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 yes?
Is there a reason why all the answers are coming out to negative 5? Because
No, it's like some cosmic universal alignment that has him going like, BAM! Negative 5. Now, let's see if we get a negative 5 on this one. Yeah. All right, so the big thing about this question, the reason it's the second most deadly math problem in the whole world, well, buy from this beauty, you're born on. The reason it is kids constantly think that this negative sign right here has something to do with the 3. It has nothing to do with the 3. The 3 is positive. So I have to do the opposite, which is a negative 3. Die. Now, here's where kids mess up all the time. What kind of 2x is this?
Negative.
So they must write negative 2x. Many kids will write 2x. They'll just kind of get very casual about that negative sign. No, it is attached to the 2. That is a negative 2x equals 10. Dividing by negative 2, die. X is negative 5. Okay? Any questions? Okay. Now let's go to the next one.
What was you?
They're all negative 5 so far, plus the last 2 on the quiz.
So there is a reason for that?
No, pure coincidence. I do think that sometimes when I make up questions, I just have like numbers rattling around in the back of my mind, and they just kind of work out that way. If you have a math brain, numbers just come really kind of naturally. My wife is continually amazed. Years ago, if I went food shopping with $100 in my pocket and I walked up to the cash register, I never exceeded $100. I would constantly come out to like 99.03, 99.71, and I wasn't keeping a running tally. It was just kind of clicking away in the back of my head, and it would just work out that way. So nowadays, I just give them the credit card, and I pay the credit card at the end of the month. But back then, I used to be able to do that very, very well. And what was really pretty surprising is I used to be one of these coupon cutters because we had no money. So I'd constantly cut coupons.
That's my mom.
Yeah, well, no, it's a smart thing to do. It's a very smart thing to do. And then I would get there, but now I just go to Costco. All right, so.
Yeah, my dad goes to Costco too.
Yep, yeah, very much so. Okay, so I'm going to distribute to 4, and that's the first thing. Now, lipstick. When I distribute to 4, what do I get?
12 and minus 20 and not
Just,
10.
just 20, right, equals negative 42. And then minus the 12, die. This is that danger situation, right? Oh, that's 12 n. Oh, oh, I did a boo-boo. Hold it. I misread that. I didn't see the n there. Hold on. Let me go back to this. 12n minus 20 equals negative 42. Add 20. Yo muy malo. 12n equals negative 22. And I divide by 12, and I get an ugly number. There is no guarantee in this universe that numbers will always be pretty. So negative 11 over 6. Do we convert that to a decimal?
No.
Decing, do we convert that to a decimal?
No.
No. Good boy, Decing. Now, let me show you the way I would do this. I would not do it the way I just did it. I would do it this way. Let's try to understand what's going on with equations, okay? With equations, as long as you do the same thing to both sides, the equation is balanced. But you must make sure it affects everything on both sides. So the first thing I see here is that I'm multiplying the left side by 4. So I'm going to divide the whole left side by 4 and the right side. Die. I get 3n minus 5 equals, this is going to be negative 10 and a half. Right, because 4 goes into 40 10 times and 2/4 is left over. And then I'm going to add 5. Die. I get 3n equals negative 5 and a half. And then I would divide by 3. In this case, it's a little bit ugly. This works out to be negative 11 over 6. I don't really want to get too into how I manipulate that. Basically, you double the top, double the bottom, you're going to get negative 11 over 6. What I want you to realize is that there is this technique where you can divide both sides by 4 right away. And then had this been a whole number, it would have been very easy to do. Okay? So I want you to see that both of those are available to you. All right, any questions? All right. So, has anybody peeked at the school calendar for the year?
No, I lost my
Oh!
agenda.
Why?
I do every day. Like that one?
Well, no, not just that one, but like, have you looked at the whole calendar for the whole year?
Never.
Oh, yeah.
Never.
No.
All right, Chloe, what did you notice this year that's really, really, really got the potential for great coolness?
Nothing.
Nothing?
A
No,
4-day
there's
weekend
something.
and a
No
3-day
vacation
weekend, 2 times in a row.
Well, that's in the immediate future, sure. No, there's a wonderful thing that is potentially going to happen this year.
Oh, solar eclipse. That's a thing.
No, the school calendar. What is so cool about this school calendar is, now, we have the shot at 6 days off from Memorial Day.
What?
Memorial Day is like, first off, you've been in school since September, it's the end of May, you want a big break, right?
Yeah.
6 days at the end of May is really cool.
Yeah.
But what's even better is the weather is beautiful. It's the opening of the beach season. Fly fishing is great. Photography is great. I go upstate, spend a few days.
Nice.
It's just a beautiful, beautiful time of year. I can even go to Maine if I have the money and do a little bit of fishing up in Maine. So, here's the deal. I don't want you to raise your hands. I'm sure some of you believe in God, I'm sure some of you don't. I am sure there are moments in time when you all believe in God, every one of you. Even if you say, I am a hardcore atheist, I will never believe in God. Well, the truth of the matter is that there are moments when you do believe in God. And I know that because you pray. Right before the possible snowstorm in the wintertime. You get on your knees like, please God, no school tomorrow, no school, please, I don't want to go to school, I don't want to go to school, please, 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 snow day. And then when they get on the thing and they go snow day, you're like, yes, 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 yes!
I thought you'd be happy about that.
Well, and here's the thing, you're doing it all wrong. You should be praying for a 2-hour delay. That's what you want.
Exactly.
Go
Pray to go home early, 'cause that's what
Going home early is okay, it's snow day, 2-hour delays. You don't want a full snow day. Because then they take the days off the Memorial Day vacation.
Well, I still wanna go to school.
I thought we had set
Yeah.
snow days.
What?
I thought we had set snow days.
Yeah, don't we have a bank?
No, what they do is, listen, they kind of plan on 3. And what they did with Memorial Day was they said, okay, we're gonna put these extra 3 on Memorial Day. If we don't use any, you get these days off. If we use 1, we're gonna pull this one back. If we use 2, we're gonna pull this one back. So they're letting you know ahead of time. So the really cool thing is if we don't use any snow days this year, if they don't use any snow days, we get 6-day vacation on Memorial Day. Now, when you hear of the potential for snow, please, 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 and you suddenly turn religious, pray for a 2-hour delay. Don't pray for the whole snow day. Just in case there's any cosmic significance between your prayers and 2-hour delays. I don't know if there are. I really don't know if even if you believe in God, I don't know if God's real big on snow days. But it is what it is. Let's go for the 2-hour delay. 2-hour delays are wonderful. Now, the reason I bring it up is because we're about to study properties in mathematics. And we've studied the distributive property, okay? To distribute means to give out. When I think of the word distribute, I always think of the Great Depression. That's one of 2 things I think of. A typical distributive property might look like something like this. 5 times x plus 4. And when we distribute, we give out that 5 to everything in the package. Now the reason I think of the Great Depression was a horrible time in our country's period in our country's history. And honestly, I do believe that we are teetering on that same exact time right now. Our country is $20 trillion in debt. Debt needs to be paid. Yeah, it's really terrible. And what happens is we're in such a precarious position that if that debt is called in, then no one will have money.
Ronald Reagan 2016.
Yeah, wouldn't that be great? So what happens is, in the Great Depression, this kind of thing happened and our economy absolutely crashed. And there were tent cities down by the bay. People lost their houses with regularity. And they would live in tents on the bay. Now, you might say that's not such a bad thing until winter hits. And people had no food. And on Main Street, they would have what they call soup kitchens. They would have a place where, and there are some are active even now, but they tend to be only open on Saturdays or Sundays. Soup kitchens would be open every day of the week. And with these soup kitchens being open, people who had no home and no money and no food, they would go by the soup kitchens and they would get on a line just like you do in the cafeteria, and they would give out soup so they would at least have something to eat. And it was called distributing the soup, giving out the soup to each person as they would come through. Kind of like here, we give out the 5 to the X and the 5 to the 4. So whenever I think of distributing, I always think of that. Now, another thing I think of with distributing is Christmas. So I have the bleak picture and then I have the happy picture. I remember Christmas because my 2 sons would distribute the Christmas presents. What they would do is they would go underneath the, under the Christmas tree. You can like leave it there next time. So they would go under the Christmas tree, they would read the tag on the present, and then they would bring the present to whomever's name was on the tag. So they would distribute or give out the Christmas present. So that's an example of the distributed property. And in this case, we would multiply the 5 by the x, which would give us 5x, and the 5 times the 4, which would be 20. And that's an example of the distributed property. We've done it already for a couple of days. We've done it on quizzes. I've seen you do it, with the exception of one person who made a really stupid mistake. Then I think we're all good as far as that goes. But the reason I brought up Christmas time is because the next property we're going to talk about is called the commutative property. Now, the commutative, if you look at the spelling on your paper, it's C-O-M-M-U-T-A-T-I-V-E. Many kids write commutative. It's not a community, okay? We're not all gonna go to a commune, sit around and sing Kumbaya, all right? Yeah, this is not what it is, okay? It's the commutative property. And the time that you hear about the root word of commutative is the word commute. And the reason you hear about that is potential snow days or potential weather events. 2 mornings a week, I go to the River Avenue Deli and I grab breakfast at about 7 a.m. I get a bagel, usually sesame, gutted, which means you pick the bread out of the inside, with a ham and cheese omelet on it with ketchup. It's my standard breakfast. I gotta call up and say, hi, it's Bob, can I have breakfast? They know what to make me. Now, so I sit there and I watch the little TV they have as they're making my breakfast. And the TV will talk about the morning commute. That's the root of commutative. Now, does anybody know what the morning commute is or commuting is?
People going to the city?
Yeah, and then they reverse it and go from the city back to here. See, in the mornings, they get on the train in Patchogue, or they drive from Patchogue, and they go into New York City, bless you, because that's where the jobs are. Then they work in New York City, in the afternoon, they turn it around and they come back. That's called commuting. You go in one direction on the way there, and then what do? Turn around and you go in the other direction on the way back. So if we look at this diagram, this is a picture of 3 plus 4. When I do 3 plus 4, how many tiles do I get? Everybody?
7.
7. This is an example of 4 plus 3. How many tiles do I get?
8.
7.
7.
Again.
So notice that it's the same either way. And that's the next thing that it says on your paper here. It says you get the same answer either way. You could switch the order of the addends, which is a technical name for the things you're adding, and you get the same answer. We say that this is commutative. Notice the spelling, and there is the root word commute for commutative. And that commuting would be New York to Patchogue, and then I turn it around and I go Patchogue to New York. So if you look here, 5 to 4, 4 to 5. I turn it around, and that's why they call it the commutative property. In this case, what do both of these make?
8.
9.
Oh, man.
9 equals 9, correct. Now I see why you never get that 100 on the first quiz. It's always that just one thing. Now, this would be the commutative, A would be the commutative property of addition. Now, I can remember, oh, the memories of when you're a kid. I remember cheating on a quiz once. I was in, I believe, 7th grade math. I was in 8th grade math. And we had this quiz, and as they're giving us the quiz, I peek over at the side, and I see that the question was like this: what's the absolute value of -3? And on my quiz, I put 3. And then the teacher called on me in front of the whole class and said, how come the answer's 3? And I was like, I have no idea
Because
why.
it's on the train track.
No, okay, well, whatever the case, I also remember one time on homework, knowing that this was the commutative property, and I could not figure it out if it was for addition or multiplication. Okay, what is that symbol?
Addition.
Addition, so it's the commutative property of addition. And the last thing I want to talk about is what we call the associative property. Have you ever gotten in trouble when you're a little kid and your parents look at you and say, you will not associate with so-and-so? I can remember doing it for my kids. To associate means to be grouped with. So, if I take a look at letter B here, ready? You see how the 5 is being grouped with the 2? And then over here, the 5 is being grouped with the 3? If I change the parentheses and I change who the middle guy is being grouped with, that is the associative property. Here, look at the 5 being grouped with the 4, 5 being grouped with the 8. That's the associative property of addition. B is the associative property of multiplication. I'll talk to you a little about the other one tomorrow. That's exactly right. Hasta la vista, vaya con Dios, toodaloo, ta-ta. Arrivederci. Smile a lot. Ciao. Arrivederci. Adios, amigos y amigas. Cheerio. Hasta la bye-bye.
We don't even. Sorry, guys.
Thank you, sorry. Okay.
Water bottle?
What?
Have fun.
If I